One of the most important things when we are talking about AI agents is the Model Context Protocol. So this is basically just giving agents, AI agents, large language models, and all those tools. It gives the models access to call external services through MCP servers. So this is what we're going to go over in this video here. We're going to go through some examples, how it works, why you should consider using MCP servers, especially if you're working with large language models, AI agents, whether if you're just working coding and so on, you can hook up MCP servers that can put it in thinking mode. You can connect to all different types of tools, or if you're building actual AI systems. So let's just jump straight into it here. We have a blog post covering like full details about Model Context Protocol. I'm going to talk about it in detail in this video as well. Tons of blog posts, videos on the YouTube channel and so on. Make sure to check those out. So Model Context Protocol is from Anthropic. It's very popular, like it's growing so much right now because it makes it so easy for the AI agents to have access to tools, different servers. So let's say that you're creating an AI agent that can go out and scrape the internet, pull some information on a daily basis, and then send you an email. Could also be send you a notification on Slack. So all these integrations that we're thinking about. And then you're probably thinking about API integrations where we talk with an API back and forth, but the MCP servers here, they centralize it a bit more, but also still makes it more decentralized, where we just have one client that can connect to multiple MCP servers, and then the large language models have access to those tools. So then when you give the large language model or AI agent an input, it has access to all these tools based on the input query, the input prompt that you're throwing into it. It will go through it, think about, do I need to pull out one of the tools that I have in my MCP servers and do some action? So this is what takes it from just generating text to act like taking actions and doing useful stuff. And you can connect multiple steps in a pipeline to automate tasks. So inside the blog post here, we have a pretty good visualization just showing the MCP architecture, where we have the MCP clients, could be your own MCP clients, tons of different frameworks out there like the Agent SDK from Google, all different types of MCP hosts if you have Google or Claude Desktop on your computer, Cursor, Copilot, and so on. Those tools are actually like acting as a MCP client that can connect to multiple MCP servers. Then we have like a converter here, or basically this dongle that can take multiple USB ports as input and then just has one USB output going into your computer. So this is pretty much how it works. If we were talking about like just standard AIs, we need to actually connect each of these USB ports into our computer, but could be cases where we don't have enough USB inputs. It's just harder to play around with. It's harder for having a new agent that does all the setups. If you want to transfer the system, if you're multiple people working in a code base, you can just have your servers hooked up. They can come from different sources, and everything is centralized and defined over the same protocol instead of just using MCPs. So you could have an MCP server connected to your local data sources. You can have an MCP server to your Google Calendar, Gmail, Slack, and all different types of resources. Could also do web search. It sends a notification on Slack. It pulls your emails and your calendar. It can schedule emails and it can schedule meetings based on your inbox and also your calendar availability. So if you scroll a bit further down, we also have the visualization where we have these unified APIs that goes into an MCP server, and then we just have one unified API or connection with our Model Context Protocol that hooks directly into the large language models. So it just makes it easier because the large language models, they're not perfect. They can't have access to all these different APIs. They are actually like built for tool calling, especially the Claude models, and they're significantly better at calling the MCP tools compared to just setting up individual APIs and giving it access to that. Also a lot more setup, especially if you want to have multiple systems, multiple different backend systems sitting on top of your API connections. It's way easier to just have an MCP server, and then all your different clients can just connect to that MCP server. So we could actually add another service up here that connects to your LLM or your MCP. So it doesn't just have to be one unified connection, but it could be multiple LLMs or multiple services that you have in your code base that connects to one MCP server. We need to act like if we had multiple up here, we need to create a unified API connection to each service or LLM that we have running. So this is probably the most important thing to think about when we're comparing APIs, MCP servers, and why they're so powerful. And one thing is for sure, they're only going to get better. So here we can see some key components of the model context protocol. So here how it works. The system checks what it knows. So when the user asks it something, the large language model, it actually goes in and looks at all the tools that it has available, chooses if it actually has to use a tool to generate a response for the user intent. If it has to do that, it will then call the tool, get the response back with the connection that it's doing. Could be reading your emails. It will get a response back with all the text, maybe all your emails, throw that into the large language model, generate the response. And then maybe based on that output, it needs to go into your calendar or do something else, send you a Slack notification that you have an email reminder or whatever workflow that you're setting up. So it builds a request, the request reaches the server does the work, the server replies, the assistant answers. So this is pretty much just what I explained as well. We have the AI host, Claude Desktop, ChatGPT, Cursor. You can build out your own MCP client that just connects to the MCP server. And then you can also have data sources sitting at the lowest level, have MCP servers directly hook up to your database. Just imagine a chat with your data chatbot. We don't have to build out like a full RAG-based system unless we want to have some semantic embeddings, do some layer search and all that. But if you just have some data, numerical data, it can be text-based data and so on that we just need to pull and do keyword-based search, you can have an MCP server just sitting on top of your database directly. Then once in the MCP client or in your application, you ask for something about your data. It's going to call the data MCP server. It goes down, uses the tools, finds the relevant data in your database, sends it back to the LLM, and it generates a response based on the data. So it's very, very powerful to connect to multiple data sources, connect different services on top of it, as I mentioned as well. And this is like the most value that you get out from it, and also the whole idea behind MCP. Software development, enterprise assistance, you can have like a customer service just sitting on top of all your data. You can build out multiple MCP servers in your company, and then you just have clients connecting to the MCP servers that it needs access to. Then a whole nother level is to get agent-to-agent protocol from Google on top of it as well, where we basically just have a description or a business card for each of our agents, and then one set of agents in one business can have access to MCP servers, then another business could have another agent that has access to MCP servers, and then we can have the agent-to-agent protocol connecting those agents together. Then you can have a whole swarm of AI agents where each of them basically just have a business card. So maybe you ask a question to this business department or region over here. It uses some MCP tools, figures out, okay, I need some information from another department. It uses the agent-to-agent protocol, goes over to the other agent that then retrieves the information and data from its MCP servers, and then it can send the results back as well. This is how we create like full agentic AI systems with all the new protocols out there, agent-to-agent, model context protocol here, which is very powerful. It could be a desktop assistant as well, enterprise assistant, just for software development in general. If you're using Claude Code, Gemini CLI, we have videos covering all of that here on the channel already. Those agents can also have access to MCP servers, could have web-based MCP servers, could also have local data access on your own computer. So here we have MCP host with Claude Desktop. It has access to Google Maps, your file system, GitHub repo, Slack, Blue Sky. It sits on top of all the data here as well. So maybe you get an error or you get a pull request on GitHub. It automatically sends it to Slack, creates a ticket somewhere. You can use it in Claude Code. It automatically loads that ticket, does the implementation with the code. Once it's done generating the code, you can have an MCP server or basically just test it out. It can send the results back on Slack that now this error here or ticket is basically just finished and ready for test. So when you're using MCP servers, think about like just creating a toolbox for your large language models. So you can also use MCP servers to drive like computer vision applications, hook them up. You can have MCP servers for images as well. You can have detections going into our database where you have your large language models sitting on top of your database with an MCP server. And this is how all of these things here, all the modalities are coming together. And that's actually like a pretty cool project. If you're looking to build like an AI agent computer vision project, get some detections from Ultralytics, save them into our database, then the AI agent is analyzing the detections that we have in the database and gives back a response to the user. Could also be enhancing medical imaging with context aware AI and MCP. It's just about giving the models more context. They're not perfect out of the box. They're very far from being perfect. Sometimes they're hallucinating a lot, but the more and the better context that we're giving the models, the better responses we get. That's why it's called Model Context Protocol. So here we can see some pros and cons of the MCP. Consistent and standardized communication. It's very, very big pro. Improved modularity. It's also very, very good. We have a lot of flexibility. We can build different services on top of it directly. Facilitates autonomy agentic AI, where we can build our own workflows. So there's some initial setup complexity, but again, the bang for the buck and the pros that you get up here, it outweighs the cons significantly. Performance overhead, a bit of a learning curve and so on. Make sure you understand it, but if you're already working with software, if you know about the large language models and so on, you can get into it relatively easy. And again, the pros, they significantly outweigh the consequences. Hope you learned a ton this video here, ton of different information. Make sure to both check out, go through the video again if you don't understand it, research MCP servers, go through the video again, go through the blog post here in your own tempo. Learn it, because this is how the AI agents are gonna work in the future and already are working now. Hope you learned a ton. Hope to see you guys in one of the upcoming videos. Until then, happy learning.